Hi, my name is Stacy Cisnero, and today I'll be discussing the impact of magnetic resonance imaging, also known as MRI. Magnetic resonance imaging is defined by Wikipedia as a medical imaging technique used that is able to produce images of the internal organs. It's been used by professionals to make detailed images, which can then be used by doctors to diagnose the patient and give them the proper treatment necessary. In my table of content, you'll be able to find the purpose, effects and impacts, technical aspects, relationships, data, and my reference page. On this slide, I'll be discussing the purpose of an MRI and the opportunities it has created. The purpose of magnetic resonance imaging is to produce three-dimensional, detailed anatomical images without the use of damaging radiation. It uses strong magnets and radio frequency pulses to generate signals from the body. Magnetic resonance imaging is used to detect, diagnose, and monitor how treatment is going. They can point out the difference between white and gray matter, as shown in this picture to the right. The opportunity that the innovation created is that it has made it possible for diseases to be diagnosed early. It allows for doctors to have a wide range of information about your body. In this slide, I'll be discussing the benefits and harmful effects of an MRI, the impact it has had on society and the economy, and in other fields other than computer science in which this innovation has impacted. MRI provides better soft tissue and can differentiate between fat, water, muscle, and other soft tissues compared to CAT scans. MRI contrasting agent is less likely to produce an allergic reaction that may occur when iodine-based substances are used for X-rays and CAT scans. There aren't any extreme harmful effects of an MRI. However, there are some risks to keep in mind. Some patients have reported the inside of an MRI scanner to be extremely small and uncomfortable and may experience claustrophobia. Imaging in an open MRI scanner may perhaps be an option for some patients, but not all depending on their case. In order for an MRI scan to be completed, the patients must remain still, which might be a problem for some people, especially infants. MRI has had a variety of impacts on society and the lives of people as well as the economy. It is used to look at abnormalities that could perhaps save their lives if it is caught early. It makes it easier for doctors to accurately diagnose a patient as well. It has impacted economy a lot as well because it has allowed for new technology to be invented in the medical fields, which brings in a flow of money since they're being purchased. On the left is a survey I conducted where I asked my classmates how much they thought magnetic resonance imaging has impacted their lives on a scale of 1 to 5. As you can see, a majority chose 5, meaning it's had a high impact. One field other than computer science, which magnetic resonance imaging has impacted, is the medical field. It has caused a significant step forward in new technology. It has allowed for the development of magnetic resonance spectroscopy. I've included a picture to the left of what it looks like. MR spectroscopy are a series of tests that are added to the MRI scan of your brain or spine to measure the chemical metabolism of a suspected tumor. It helps doctors determine the tumor type as well as the aggressiveness of the tumor. I created this video about magnetic resonance imaging because I wanted to see how informed my housemates were about my topic. Okay, so what are some of your beliefs of the impact of
I think MRIs are great because they can help doctors diagnose diseases and disorders before they worsen, and they can reveal hidden symptoms or abnormalities that other like imaging techniques don't, like CAT scans or X-rays. They have a nice detailed image of what is in the soft tissue or the brain or spinal cord. So I think they're great and very useful for doctors.
They are non-invasive and do not use radiation. They can easily create hundreds of images from almost any direction and any orientation. MRIs can determine if a cancer has spread and help determine the best treatment. Disadvantages include that they will not be able to find all cancers.
I've also included another video in case you guys have any more questions. In this slide, I'll be describing how a user interacts with innovation, how the innovation incorporates one of the big ideas of abstraction, algorithms, program, and or the internet to accomplish its purpose. Let's begin with how a patient interacts with an MRI. A person getting an MRI done will be asked to lie on a scan table and will be given a buzzer to hold. This buzzer will allow you to speak to the radiographer, also known as a medical imaging technologist. When you squeeze it, the part of your body that is being scanned will have coils placed around it. This will pick up signals from your body so that the computer can create images. The radiographer will use software to select imaging parameters as well as administer pulse sequences. The scans are passed to a radiologist when the scan is complete, and then a written report will be sent to your doctor who can evaluate them and give you the right diagnosis or treatment. MRI incorporates the internet to accomplish its purpose. Radiologists have developed a remote control mechanism that allows specialists to control an MRI machine by logging onto the internet from a personal computer. A remote control can control all the imaging parameters needed to conduct the exam. The internet is also used a lot by technicians to run diagnostics on an MRI that has failed in their office. In this slide, I will be discussing how the innovation consumes data as input, produces data as output, as well as data storage concerns and the data security concerns related to the innovation. Magnetic resonance imaging exams consumes data as input by producing images of internal organs and the structures of the body without the doctor having to cut open your body. The innovation takes pictures of the body that contain water, and the images comes from the way different tissues interfere with the electromagnetic waves that are coming from the water molecules. A single proton is used because of its abundance in water and fat. The signal creates the magnetic resonance imaging because the machine excites the water molecules into releasing waves, which creates a signal and then produces data as output by recording those waves with high accuracy. Data storage and data privacy concern is one concern researchers in medical imaging are dealing with. It is driven by government regulations, grant rules, and technical advances. The security of the patient's data is becoming more challenging because providers need to share information with other providers if the patient moves, for example, or wants to be seen by another healthcare provider. Cloud sharing allows for the data to be shared, which makes the image transfer faster. However, there's a lot of worry and uneasiness about the technology. Think about it this way. You're getting an MRI done, and you leave thinking your information is being stored. But think about how many other people are also getting an MRI done and how much data needs to be available. Over here is my reference page, which is where I got all my information from. I used coding to write this paper. I used HTML and CSS styling to create it the way I wanted. As you can see, this is my index page. Over here I have my button, my animation, which is in the front, which is my GIF, which I created with Pixlr. I also included my paragraph on my abstracts page and these hrefs links that connect to the pages. Over here is my style CSS page, which is where I created how I wanted it to look like. I have my background color, the border. These are from my pictures. Font size I was able to change. And as you can see, if you go back to my page, I can go back and click my banner, which I also created on Pixlr, and it brings you back to the first page.